Good afternoon, everybody. Hope y'all are having a fantastic day so far. Today we're going to be talking about trig ratios. Now, if you were in class for our talk on the unit circle, when we finished up our unit circle, today's really not going to be that big of a difference. We're going to get into our trig ratios here. So we have a distance r, which is your radius. It's a distance from the origin to a point on the terminal side of an angle. Thinking about that as like our radius from our unit circle, that's kind of the same idea here. So since r represents a distance, it's always positive, right? Distance is always positive. So for a couple of things here, if your point is x comma y, that means that your x values or how wide you had to go, and your y values or how far up you had to go, right? So it's how far over and how far up or down. So for a given value of theta, the ratios y over r, x over r, and y over x are constant. Remember, that's sine, cosine, and tangent. The ratio, remember, trigonometry is the study of the ratio between sides and angles. So the ratios y over r, x over r, and y over x are constant for any point P on the terminal side of angle theta because of similar triangles. Therefore, each of these ratios is a function of theta. So here's your trig ratios. Now, this isn't going to be new if you have your unit circle stuff already in hand. Sine, first off, you have sine theta is equal to y over r. Cosine theta is x over r. And tangent theta is y over x. Okay, now those we've seen before, we've dealt with them before. Some of you may have seen these next three. But if this is your first time, the next three are called reciprocal trig ratios. And right above there, let's just write that word. These are the reciprocals. When you think about a fraction like 2/3, the reciprocal of that is when you take the fraction and you flip it, right? You just take that fraction and flip it. Cosecant is the reciprocal of sine. Draw yourself a little arrow right here. That shows that these two are related. Cosecant is the reciprocal of sine. So we abbreviate that with C. SC theta is R over Y. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Excuse me. So you've got SEC of theta is the reciprocal of cosine. So that's going to be R over X. Tangent and cotangent are obviously reciprocals. So cotangent is COT theta is X over Y. A lot of people get the sine and the secant confused for being reciprocals because they both start with S, and the cosine and cosecant both start with COS. If you remember it this way, between sine, cosecant, cosine, secant, tangent, cotangent, each pair can only have one co, if that makes sense. Like you got sine and cosecant. You've already got a co in sine, so cosine and secant, right? Tangent and cotangent. So each group can only have one co. That's kind of how I remember this thing. All right? So you got sine, cosine, tangent, cosecant, secant, and cotangent. Your trig ratios. All right, so let's figure out where this thing's actually going to be used at. Excuse me. Let's say that the terminal side of theta in standard position passes through a point P. Draw theta, find the exact value of the 6 trig functions of theta. Okay, so you've got a point P that's at 6 comma 8. So let's go over to 6. Ding. So it's at 6 comma 8, right? Alright. And it wants me to find the 6 trig functions. I'm going to bring this 8 over here and label it. Well, there's a couple of things I need to figure out first. Number one, how big is my radius? Because it's obviously not 1 anymore. Now I can do that with good old Pythagoras. 6 squared plus 8 squared is equal to c squared. That's 36 plus 64 is equal to c squared. That's 100 equals c squared. So c is 10. Right, good old Pythagoras. So now these are really simple. Sine theta, right? Cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta. So you've got sine, cosine, tangent, blah, blah, blah. So sine was y over r. Y is 8 over r is 10. So we simplify that to 4 over 5. Cosine is x over r, which is 6 over 10. Simplify that to 3 over 5. But keep in mind, these are your answers here. The cosine of theta is 3/5. Tangent is y over x, 8 over 6, which is simplified to 4/3. Cosecant of theta is the reciprocal of this. So it was r over y, right? 10 over 8. The reciprocal of this. Well, you know that's going to simplify to 5/4. Just flip your answer here. Secant would be 5/3. Again, if you put 10 over 6, you'd simplify to 5 over 3. Cotangent is 3 over 4. And again, that's 6 over 8, x over y. So that's not too terrible. And that's how you come up with all 6 of your trig ratios. Yay, trigonometry. All right, let's try 2. 2 says -4 comma the square root of 2. -4 square root of 2. Well, here's -4. And then you're going up the square root of 2. Now, I don't know how necessarily on this graph how big the square root of 2 is, so I'm just going to put it in a positive direction. Technically, the square root of 2 is like 1.4 something, I think. But, nah, who cares? It's positive, that's all that matters, and it's just a drawing. So here's my theta, right? Oh, I didn't label my theta up here. Bam. Here's my theta. All right, with this one, we got to get used to labeling theta here. Here's my theta. All right. So we're going to do some good old Pythagoras again. Let's see what our hypotenuse is going to be. We've got -4 squared plus square root of 2 squared equals c squared. So this is going to be -4 times -4 is positive 16, plus the square root of 2 squared is 2 equals c squared. So you've got 18 equals c squared. Take the square root of both sides. Square root of 18. Now I've got to simplify that. I can't just leave it like it is. So I am going to simplify it a little bit here. To simplify your rationals, remember to simplify a square root. All you need to do is take the prime factorization of this. We call it a factor tree. So 18 divided by 2 is 9. and then 9 gives you 3 and 3. So when you break it down to just prime numbers, if you have a pair, then they're going to go outside of the square root. So that's 3 square root of 2 equals c. I'll do some of these in class tomorrow, where you can actually get a little bit of practice with this, because I know it's been a while for some. 3 square root of 2. Now all we have to do is set them up. So you got sine of theta is y, the square root of 2 over 3 square root of 2, which simplifies to 1/3. Right? I'm going to write that a little bit bigger. 1/3. You got the cosine of theta is x over r, so that's -4 over 3 square root of 2. Now you know you can't leave it like that. You know you can't leave it like that because the square root does not go in the bottom. So just like before, times the square root of 2.